Hello. So we're going to start looking at chapter 4.4, which is solving exponential and logarithmic equations. I'm going to divide these videos into two parts. The first part, we're going to be looking at solving just the exponential equations. So, when solving an exponential equation, if we have an equation of this form, where the bases are the same and we have exponents, then if the bases are the same, we can conclude that the exponents are equal. So what we do when doing one of these problems, let's look at an example, is we try to make the bases the same. Looking at this particular problem, it doesn't look like the bases are the same. Here it's a 5, here it's a 125. But we know that 125 is really 5 cubed. So we can rewrite this problem as 5 3x minus 6 equals 5 cubed. Now, since the bases are the same, all we have to do is look at the exponents and realize they're the same as well. So then we can equal them, and then we just solve it like normal by adding 6 to both sides, then dividing by 3 to get our answer. Let's look at another example. This one is a little harder, but we do know that 8 and 4, that 8 is really 4 to the second. So we can rewrite the left-hand side as 4 to the second, and that is raised to the x plus 2 power. Right-hand side doesn't change. Now we need to use the property, the multiplicative property of exponents that you picked up in developmental math to rewrite this as that. So we basically foiling out the exponent. Now that they have the same base, you can set the exponents equally to each other, and then solve accordingly. Subtracting 4 from both sides, subtracting x from both sides. We get x equals negative 7. However, what happens when we can't easily figure out an equal base? What if we have a problem that we can't use this trick? Then what we're going to use is we're going to use the properties of logs to move the exponent down. Okay? So let's look at a simple example for how to do this. 4x equals 15. Now there isn't an easy way to rewrite 15 as a base of 4 with some exponent. Now you can rewrite 15 as 4 to some exponent, but it's going to be not a natural number. Okay? So what we can do here is instead we're going to use the property of logs. And we're going to take the log of both sides. I'm going to use natural log just because it tends to be what you usually use in these problems. And I'm going to take the ln of both sides. We can do this. This is allowed. Now the property of ln states that exponents are going to come down on the outside. So we go ahead and do that. Property from last chapter. Okay. And it becomes multiplication. Then all we do is we know this is a number. This is some number. So this is really like some number times x. And we're going to divide both sides by that number to solve for x. Okay. So x equals ln 15 over ln 4. If you want an actual approximation of a number, you'd have to plug it into a calculator at this point. And when you do that, you'll get x is approximately equal to 1.953, and you're done. Look at another example. Okay, in this example, 10 to the x equals 80,000 or 8,000. We are going to use log base 10. I could use ln, it wouldn't matter. You get the same answer. But I'm going to use log base 10 because we know that the logs cancel each other, log and 10 cancel each other out. And we end up with this. So all we need to know is what log of 8,000 is. At this point, again, we'll have to plug it into a calculator. And we do, and you'll get x is approximately equal to 3.903. Let's look at another example. All right. Now with this example, we know since it has e, the easiest thing to do is use log base e, or what's called natural log, or ln. But before we do that, we need to get rid of this. Yellow's not showing up. This, here, and that. And the reason for that is ln does not distribute across subtraction or addition. We talked about that last time. Logarithms will distribute across. There's rules for distributing across multiplication and across exponents. But there isn't a rule, an easy rule for distributing across addition or subtraction. So before we take the log of both sides, we definitely need to take care of this guy. We don't necessarily have to take care of the 7, but it's easiest in this case if you do. But you definitely have to take care of this 5. So what you're going to do is you're going to add 5 to both sides. Here they cancel. And we end up with this. Now I will go ahead and get rid of the 7 by dividing 7 on both sides. Get e to the 2x equals 9. Now, we're going to go ahead and use the natural log, which is known as ln. Take the ln on both sides. And the properties that we talked about last time, we know that ln and e will cancel each other out. And you'll be left with just a 2x equals ln 9. Divide both sides by 2. And you'll end up with your answer. At this point, if you want an actual number, you're going to have to plug it into a calculator. When you do, you'll get this as approximately equal to 1.099. Okay, let's look at another example. Okay, so here, it's going to be a little bit longer one. We have exponents. We don't have any addition or subtraction outside of any exponents, which is fine. That's what we want. So unlike in the previous problem where we had a negative right here, we don't have any subtraction outside the exponents. So I'm going to take the natural log of both sides. Like that. Okay, and we have the property of logs where exponents come down. This is a very useful property. We're going to use it a bunch here. So this exponent comes down, this exponent comes down. It becomes multiplication when you distribute it through. So it's 2x minus 1 in parentheses times ln 3 equals ln 7. Oh, wait, I want to write it. X plus 1 times ln 7. Okay. Now we're going to go ahead and distribute. Ln 3 is just a number as well as ln 7. We're going to distribute that number to both terms, just like we'll distribute the ln 7 to both terms here. When we do that, we'll get 2 ln 3 which is a number, times x, minus ln 3 equals ln 7 times x plus ln 7. At this point, here we have this right here. This is just a number. It's times x. So we have a coefficient times x. Again, this is just a number and it's times x. So we're going to move all the x terms to one side and all the constant terms are here and here to the right-hand side. So you have 2 ln 3 x minus ln 7x equals ln 3 plus ln 7. So I just moved it by adding the ln 3 to both sides and subtracting the ln 7x from both sides. Okay? Then what I'm going to do is I'm going to factor out the x. Both over here, both these two terms have an x. I'm going to factor the x out in front, group what's left. Okay. And then from here, this right here is just a number, as is this. So if we think of this as like 5x equals 10, we'd know what to do. We divide both sides by 5. So here, we're going to divide both sides by the 2 ln 3 minus ln 7. So when you do that, x equals ln 3 plus ln 7 over 2 ln 3 minus ln 7. Okay. At this point, if you actually want a number, you're going to have to plug it in the calculator. Okay? But you could, and you could work it out and figure it out. But if they want exact answer, you'd leave it as this. Okay, let's look at the last example in this part. Okay, so we have these are exponential. It's really a function of exponentials. We're going to have to do u substitution to solve it. Okay, so you remember doing u substitution, beginning part of the semester. So what is u substitution? With u substitution, you always make the lesser term here, the one that's not squared, your u. So this is your u. So u equals e to the x. And then we're going to square u. So if we square it, you're going to get that, which we know this is really e to the 2x. So we know that this u squared is going to be here because these are the same. Okay? And we substitute in our u to get u squared minus 8u plus 7 equals 0. Okay? Now, we can factor this. We know that a negative 7 times a negative 1 is positive 7. And we know that negative 7 plus a negative 1 is negative 8. So we know how to factor this using our rules. Factor this becomes u minus 7 times u minus 1 equals 0. You set each of them equal to 0. Here you get u equals 7. Here you get u equals 1. And we've solved for u, but we weren't really solving for u. We're solving for x. But we know what u is. U is e to the x. So here we have e to the x equals 7. Here you have e to the x equals 1. Okay, we're going to take ln of both sides to get rid of the e to the x. Okay, here the ln and e to the x cancel, or the e, not the e to the x. And we're left with x equals ln 7. Here, ln and e cancel, and you're left with x equals ln 1. Well, the log of 1, all the logs, whether natural or 10 or 4 or 3, equals 0. So we know this equals 0 here. So we have x equals 0. And over here, you'd have to plug it into a calculator. If you did, you get 1.9 approximately. Okay, it's going to have more digits than that. But. All right, so Next video, we're going to be talking about solving logarithmic. So in this one, we did solving exponential. Next one, we're going to do solving logarithmic. See you later.